Hi everyone, as I started my series where I'm explaining you behind the scene of SQL and the database, in today's session I'm going to cover indexes and behind the scene of indexes. If you haven't seen my previous video, then I would recommend you go through the previous video. And as I explained in my previous video, I will keep my content simple to explain the basics as opposed to keep it exact theory and make it complex. Alright, so for today's session, we are going to cover unique and non-unique indexes first. Then we'll talk about the role of cardinality in indexes. Then we'll talk about the composite index, and then how the indexes are used when there are multiple tables are being joined. And at the end, I'm going to cover that what is the importance of stats collection in database query tuning. Alright, so let's get started. So this was the example which I used in previous session, and we will use it for the explaining unique and non-unique indexes. So on the left hand side, yes, you see that there is a query where we are trying to search employee by the name, and then on the right hand side we had employees data and then index, and then we were doing a find an employee, and since employee index was more of like a map, so that's why we just did a search by map, and that's it, whatever the result we have given. However, if you have noticed in this, the index was having the list of employee as the value, so it did not have one single value, but it had multiple values, and that's what is the example of non-unique index, where for given key you do not have a one object, but you may have a more than one rows matching the value. Usually remains to be not one single object, but a more than one object. As opposed to that, a unique index could be an example where the key is unique and such that you would always have only one single object available for that particular key. So it could be anyone. Can first name be a unique key? Possibly not, because there would be multiple employees which would have same first name. But there could be other IDs, maybe a social security number, maybe employee ID. There could be other IDs. Based on that, you can say that those particular records are supposed to be a unique. There are two advantages of unique index, but one of the advantage is that now the database, if you have defined the index as a unique, database always know that there would be only one object available, and when it needs to choose between multiple indexes, it would be helpful. And the second advantage is if you define a unique index, then if you are trying to do an insert or update, and if it does violate this uniqueness, the database is not going to allow, so that can actually also control the quality of the data. Alright, okay. So in this example, I kept that for simplicity, I kept indexes which were storing the object itself. But in reality, when the data is stored in the database, the data is not stored, the indexes do not contain the entire data set. As opposed to that, in the Excel example which I have given, it usually the indexes have a reference. So in this particular case, this is where the data has been stored, and the indexes merely have the key and the reference of the data which has been stored. So at any point in time when database need to fetch the actual object for an index, it first need to look up the index, get the references, and then it need to look up the object to get the real object. Alright, now let's take a second example of our query. So let's say that I do have a query where we say select star from employees, where first name is Rajesh and last name is Ram. So here you can see that we don't have a search on one column, but we have a search on more than one column. On the right hand side, the representation probably would be that you have employees data, and in this example I kept it as an ID because it was relevant here, but again I will choose between keeping an object itself or IDs depending upon where it is relevant. So here you have employees, and then you do have two indexes. Let's say index first name, which is having a key as a first name and the value as all the records which are matching the first name, and then second index is index last name. Okay, now when when database need to run the select query, it needs to decide what it can do. So let's say that there is going to be option 1 where it first search the object by the first name, it get the all the IDs, then it uses get employee to get the employee object based on the IDs, and then it will iterate through this data set and then apply the remaining condition. So employee dot last name is equal to raw, and then we'll add its the final value. Now in this example option, the data was first fetched from the first index and then did iterate. We could also fetch the data from the second index, which is last name index, and search whatever the object you get, then you iterate through that and apply the first condition. So in this case you use the first index, in second case you use the second index. Now database need to make these choices based on what does it feel that which object is going to, or which index is going to give them a more efficiency, because essentially this is the cost. When you are running the for loop is a cost, so database need to reduce this cost. So that's where the cardinality comes into picture. What is the cardinality? Cardinality is that how many rows of unique keys you would find for a given index. So if you have a more unique first name, then cardinality of the first name index is going to be high. If you have a more unique last name, then cardinality of the last name is going to be high. How is that helpful? Is that database wants to reduce iterating the for loop. So if cardinality of first name is high, then there is a possibility, that means that more unique name or unique first name, then there's a possibility that IDs for given Rajesh is going to be very small, and it probably need to do a very limited for loop. If the cardinality of last name is high, then the IDs which you are going to get for given last name is going to be very small, and then database need to do less iteration to find out the real object. Now these are the first two obvious options, but database may have many other options it may also try. So the one option which I want to talk about is where it, instead of going with the one index and trying to do iterate on other, what it can do is it can actually go to both indexes, search by the last name as well as first name, get the both indexes, and then perform the intersection on these indexes, and then whatever the data has come out, it will actually do a lookup on that IDs, as opposed to iterating, getting first and then iterating other. So now let's jump to composite index. So for that I'm using the Excel as an example. So as you can see that on my left hand data set, I do have employee and these IDs and the first name and a last name. Now first index, name index, is going to look like the where key is the first name, and then the reference of the IDs of the object. Then the second index is a last name index, where key would be the last name, and then the reference of those objects will be there stored in the value. Now if you want to query, you can also create a combine index. In combine index, what happens is both the columns, or as many columns you have added as part of the combine index, will be joined together, and at any point in time when database wants to fetch the records, it is going to also join those conditions and then look up the record. So combine index could be helpful in terms of doing the iteration again. As I was saying, that there are multiple different options database give a try on. Now one of the question comes in is that, let's say that you just have defined a combine index and you do not have the normal index. In this particular case, if you have written a select query on the both columns, first name and last name, then obviously the combine index or composite index will be used. If you fire a query only on first name, then also, since the first name it is starting with, so database will still be able to leverage this index, because that's what is starting with. The first name is, or first column is, a part of the start of every key which you have. and database store these indexes in some ascending or descending order. However, if you have a query which only includes last name, then database would not be able to take the help of combined index. So depending upon what you are doing, as I said, that index have a cost as well associated. You probably need to define that whether you need to have a combined index, whether you need to have an individual index, and which column, if you are having a composite index, then which column you should keep first. Alright, now let's take a third example, which is, let's say that we are joining two tables, okay, and the table join is on employee and the department. On the join ID is department ID. Then we are querying on the employee's first name as Rajesh and the department's department name as IT. Okay, in terms of indexes, we can have index like employee. So first we have employee data, we do have a department data, then we have index which is with the first name, then we have index with the department ID, and then we have a department primary key index, and then we have department index by department name. Now depending upon multiple choices, let's say that first option what database might be having is that search the employee first for given name, get the data set, and as you can again see, I did not use the ID based fetch just to keep it simple. So get the data set, assume that when we are doing this search, behind the scene system is actually getting the IDs first and then getting the object as well. Okay, so it got the first data set, then it would iterate through this data set, and then using the second index it will try to search or get the object for a given department ID, and then it will put a condition on a department name as IT, and if it finds that this data has been matching, then it will be adding in the output. Now there is a possible another option as well, that instead of going through the employee first, database might decide to go with the department first. So search for the department name with the given name as IT, and then get the data set. Now iterate through this for loop and iterate through the department, and for every department get the employees by the department ID index, and then you get the employees, then iterate through those employees and apply your first name condition on top of that. So you can see that there is a nested loop is happening. There is a for loop here and a for loop again for the employees. And now you might say that why would database do this kind of action? It all depends upon that what does database feel that where it might find an efficiency. It could be possible that when it is trying to look up the data, it is trying to get the employee objects, it will be a slower if you get employee first, as opposed to if you try to get the department first, it might be a faster. And it all depends upon that the cardinality database has been storing, or the statistics database has been storing about these tables. As we were talking about that when database need to do the retrieval, it has a multiple different choices in terms of going with the multiple different indexes, multiple different sequencing. So how does database make that decision? Database uses the statistics of the table and the indexes and the columns to make those decisions. So in the statistics, what it stores is information like how many rows a particular table have, how well the distributed data in the table is, how are the columns are stored, how are the indexes, how many rows are indexes, or what is the cardinality of the indexes, how many blocks those indexes have, and as well as the table have. And based on that, it try to minimize the work it needs to do when it is going to do the retrieve. So if it finds that some indexes have a higher cardinality, that means it is going to result into a smaller data set, then it is going to prefer those indexes. If there are combined index, composite indexes available as and individual index is also available, it is trying to again figure it out that whether it should use a composite index, or it should use an individual indexes, or it should use a unique index, or it should use a non-unique index. All these decisions database makes based on the statistics of the database tables as well as the indexes. And that is why having the statistics accurate is very important. Because imagine that your table representation is one and your statistics, which are not done all the time, so statistics says completely different thing. For example, let's say that your table have a 5 million rows, and the stats when it was last time collected probably had only 1 million rows. Now when database is making the decision, it is not looking at the actual tables, but it is looking at the statistics, and that time it might do a guess based on the 1 million rows, and that decision may be wrong. And that is where at any point in time, if you are making a significant change in your database table by, let's say, pushing multiple millions of rows, you should always be collecting the stats. General rule of thumb is, if your DML operations, insert or update, is updating 20% of the database table, it requires the statistics collection. In general, otherwise you should be collecting the statistics at least once in a day, in probably in a midnight. Though I said that database, if you have a 1 million rows versus 5 million rows, database just looks at the statistics. This is not entirely accurate. Database also, or SQL database engine also try to do a peek into the actual data as well. It does not look at each and everything, because otherwise it is going to spend more time in finding it out or tuning the query than running the query itself. But it does a little bit of picking, and that is usually called as a dynamic sampling, where it try to actually just look at few sample records from actual tables just to verify that what the stats the data have and what is the statistics of your indexes. All right, so we have come to a conclusion of our today's session. I hope you liked it, and if you have any suggestions or any comments, please add it in comments. And if you want to cover any other topic, feel free to add it, and I'll try to cover it in my some other session. Thank you very much and have a good day.